All right, happy Tuesday, Pre-Calc, Mr. K. We're going to go through your in-class quiz review for 9193. This answer key is also posted on Schoology in PDF form, but wanted to go through video-wise, similar to what we would do in class when we go through one problem at a time so we can see these. So starting with the first two here, it says plot the following points on the polar grid, and then we're going to graph the equations too. So we'll kind of do these side by side, and I'll slide these down here. So for the first one, the main point here is the degree measurements that are not between 0 and 360. You're going to want to get a coterminal value for those. So if I add 360 to negative 450, I get negative 90. If I add 360 again, I'll get 270. Similarly, same thing here. I'll add 360 and then add 360 again. I'll get 120 for D. And for E, I'm going to subtract 360 to get 210. So that kind of makes it easier to plot these when you have all of your degrees between 0 and 360. From there, I have my R values. So for example, for A, I'm out on the 5th ring. So I go out 5 rings and I'm at 210 degrees. So same thing for E here at 3, 210. Where you have to be careful is when you have the negatives. So for example, for D, I'm at 120, but I got to go to negative 1. So that's why D is over here. For number 2, you're looking at theta equal to a value. That's just going to be a line. So this is really 225 degrees. So try to rough it in here. These are by 10. So as best you can in the middle. That line's going to extend through the entire graph. And then R equals to 4 is just a circle with radius 4. So definitely this second one here should not be too difficult for us. All right, continuing on here with this page. And this one's a little more enveloped, definitely the hardest one on page 1. So it says sketch the polar curve. You're going to use your calculator to do this. Yes, we have to sketch a curve, and you can see this is a picture of the one I drew by hand. I didn't want to take the time to plot each point in front of you in class, but nor do you have to go every 10 degrees. You don't have to have this many points, but try to put enough there so you can get decent detail. Here's a brief chart. On your quiz, there will be a chart. So you don't have to fill in the theta values per se as much as you got to go in there and just go to your table, go every 10 degrees, fill out the chart, you'll get the points for that. When I graph this, I'm in polar mode and I'm in degree mode. So that's the big thing here, polar mode and degree mode. When you hit y equals, because you're in polar mode, it's going to give you R1 instead of Y1, and I just typed in 3 plus 3 sine theta. For a window value, I just kind of went by this graph here. So if you notice the rings here, we got 1, 2, 3, 4, 5, 6 rings out to the end. So I went a little bit bigger. I went 7 to 7, so negative 7 to 7. And I'm in degrees, every 10 degrees, because that's what this graph does, every 10 degrees. And for your X scale, you can leave it as 1 if you want. I change it to 0.5. That really doesn't matter. But I just made this scale a little bigger than this graph. And when I graphed it on my calculator initially, it was mushed down a little bit. And that's because your viewing window is wider than it is tall. So the way you get around that, hit zoom after you've graphed it. After you've done all this, done your tape, plug it in, hit zoom, and then 5 for z squared, and that will square up your viewing window. That'll help you from the perspective. But again, on your quiz, the table will be there. You just have to go to your table on your calculator to fill that in, and then plot point as best you can. I don't expect you to, to draw a Da Vinci picture here, but do the best you can to get that shape. And in this case, we want to remember to name it too. It's not on the practice quiz here. They didn't ask you to name it. On the quiz itself, there'll be a blank for you to name it. So then you've got to decide, is it a cardioid, is it a rose, is it a Lee Michon, so forth. So make sure you review that, know the difference between them. Page 2. All right, distance. When we find distance in polar, that formula, remember we're still squaring our R values. So R1 squared, R2 squared. and then it is minus 2r1, r2. So we're going to take negative 2 times our 2r values, and then it's cosine of the difference of the angle. So theta 2 minus theta 1. So that's what you're subtracting there. Remember, when you square these, they're both going to be positive, so they add up to 113. This product here ends up being 112. Do not add these together. This calculation is added to the 113. So 113 plus 112 times the cosine of 165. Then take the square root, and we get roughly 2.19 or 2.2 for number 4. But again, this formula right here is r1 squared plus r2 squared minus 2 times r1, r2 cosine of theta 2 minus theta 1. And you take the square root of that. Number 5, 3 other coordinates that represent this one. The first thing we can do is we can add or subtract 360. Now you notice here they want x to be between negative 360 and 360, so we will subtract 360 from this and get negative 30. So that's my first point right there, 3, negative 30. The second two will have negative r values, so negative 3, and then I want to be on the opposite side of the circle from this 330. So I will subtract, since this is in fourth quadrant, if you're in third or fourth, subtract 180. If you're in first or second with your initial value, then add 180. So 330 minus 180 puts me here. And then I need the negative equivalent of this, so 150 minus 360 is how I got the negative 210, again with the negative r value. All 4 of these points, if you graph them, will end up in the same spot. Fourth quadrant at 330, third ring out. Okay, polar coordinates with rectangular coordinates. So I got x and y, and I need to get this in the polar. Notice this is in degrees here. You want to pay attention whether it's degrees or radians. So to find r, I square x and y. So it's just like doing the Pythagorean theorem. So negative 8 squared, 6 squared. It's going to be 100, so r is 10. Inverse tangent for my theta value. And again, that's inverse tangent of y over x. I get negative 36.87. Notice we're supposed to be between 0 and 360. So I add 180 to that, y 180, I have a negative x and a positive y. So if I have negative x and a positive y, that's quadrant 2. So that's how I know that I have to add 180 to this. Now if they were both negative, then we know we're in quadrant 3. And if you had a positive x, negative y, you know you're in quadrant 4. So make sure you pay attention to that. If you were in quadrant 4, then we would have had to add 360 to this. So our answer for theta, 143.13 degrees. R is 10. Write that as your r theta point. Number 7, rectangular coordinates. So now they're giving us r and theta, and we want to go back to x and y. Hopefully you remember from your notes, x is r cosine theta, y is r sine theta. So this is basically just plug and chug. 6 cosine of 240, 6 sine of 240. Decimal answer here is perfect, so don't worry about trying to give me exacts with square roots and all that. Just multiply it out, make sure you're in degree mode here, and write the ordered pair. Number 8, graph this equation. Don't break rule 1 with this one, please. So here's what we're going to do. For this equation, we have to solve for r, because you can't graph any polar equation unless it's solved for r. So really we have to divide. Negative 3 divided by this mess right here. So here's my equation solved for r. At that point, you can plug it in your calculator, and you're going to see that you get a line. I would use the same window that you did before. Go 0 to 360 every 10 degrees. And it says a table of 5 points. So I just put a couple points on there. You can pick whatever 5 you want. But basically, you got your line here. I try to plot these, like 40, negative 3. So I went to 40 degrees to negative 3 right there. That was pretty accurate. And then here you're a little more than 3.5, negative 3.5. So once you get your points, you can draw your line through there. Again, don't overcomplicate this. Just get your 5 points from your table, draw your straight line. Again, do the best you can with that. All right, page 3, home stretch here. Write the polar equation in rectangular form. All right, so in this case, we're going to multiply both sides by r. And when I do that, I'm going to get r squared equals 9r secant theta. Now, we know this. We know that x is r cosine theta, y is r sine theta. So if this was just cosine here, we could replace that with x and be done with it. Not so fast, my friend, unfortunately, in this one. So secant we know is the reciprocal of cosine. So if you have r secant theta, that's 1 over x. If we had r cosecant theta, that'd be 1 over y, in case you see that. So I can replace r secant theta with 1 over x. And r squared is x squared plus y squared. We know that. That's one of the 3 equations I asked you to memorize for this section here. So we just change r squared to x squared plus y squared. And this one here is 9 over x. And that's it. We're done. Don't have to solve for y. Don't have to solve for x. So again, we start here, multiply both sides by r. Then r squared is x squared plus y squared. If this was cosine theta, r cosine theta would be x, since it's r secant theta, 1 over x. All right, write the rectangular equation. Please make a note on your review. I caught this after I posted it, and then I pulled it down and edited it. So if you print it off early, you might have a minus here. This should be a plus. So please make sure that's a positive on your quiz review. X squared plus y squared, we know that right there. That's r squared right there. So r squared equals 1. If we're going to solve this for r, then we want to take the square root. So we know r is 1, and that is just a circle with radius 1. So now this rectangular equation of a circle, is in polar form. All right, dot product, a little bit of review from our vector units before. So 3-dimensional dot product, that's fine. You just take the x's and multiply them, the y's and the z's. So we multiply each of them. Here's our dot product right there. And then how do we determine if they're perpendicular? We add these 3 numbers together. If they equal 0, they're perpendicular. If it equals any other number, they're not. So this sum right here is -5. Therefore not perpendicular. And that leads us to our home stretch here. Number 12. So we got an airplane flying at 425 miles an hour due south. Due south is 270 degrees. The wind is 50 miles per hour, 30 degrees east of south. So east of south is going to be 300 degrees, because east you're going back towards 0. So here's our degree measurements now. Now we can plug them in. Our x value here, 425 cosine of 270 plus 50 cosine of 300. And then for the y values, we do the same thing with sine. I do notice here I missed one slight thing. It's not the end of the world, but we want to make sure we have this in here since these are vectors. Again, it's not a major deal, but we'd like to have it right for you guys. And then our magnitude here for x and y. So we find our x and y components. Once you have those two, you square them both and take the square root to get your magnitude. And we do inverse tangent to find theta. I get a negative theta here, so I got to add 360. So that's why it's 273.06. And again, we write our final answer, our miles per hour, at our magnitude. So that's your quiz review. Again, I'll be available for questions. I was available earlier today. Nobody logged in, that's okay. But we have another video chat this week so we can help you out. And if you got stuck or anything during the week, send me an email. I'll get back to you. All right, thanks.